modeling oligopolies using the kinked demand curve. Let's start with labeling our axes, so cost/revenue on your y-axis and quantity on your x-axis. On your y-axis, you could also put price, that is totally valid. Let's get on with the demand curve, and now you'll understand why they call it kinked. So, the first section looks like this, and then our second section is like this. As you can see, the demand curve is kinked, and there are two separate sections to it. The way we would split these two sections is by their elasticities. So initially, as you can see, it's quite elastic, then as we move on, it becomes quite inelastic. Now, there's actually reasons for this. So initially, our demand curve is elastic, and this is due to substitutes. Let's investigate why the initial section of the demand curve is elastic due to substitutes. Let's use the Coke versus Pepsi example. So, if the market price of Coke and Pepsi is at £1 and Pepsi decides to increase their price to, for example, £1.50, let's see how this will affect quantity demanded. As you can see at this new price, of course I would be using a ruler, quantity demanded has fallen quite significantly. So, for example, to 200. Now, thinking back to the start of year 12, what are the characteristics of elastic demand consumers? They are very responsive to change in price. We can see this here. Why? A small change in price has led to a massive, significant decrease in quantity demanded. A disproportionately larger decrease in quantity demanded. And why does this happen in oligopolies? This is due to the availability of substitutes. So, for example, if you saw Coke and Pepsi on a shelf in Tesco and the Pepsi was 50p more expensive than the Coke, which one would you pick? Usually, most people would pick that Coca-Cola since it is significantly cheaper. This means if firms in oligopolies decide to increase price, the demand will be elastic due to the availability of substitutes. Let's move on to the second section of the kinked demand curve, so the inelastic side of things. Now, this is inelastic due to competition, or you can say interdependence. Let's see this in action. So again, our market price is £1, where quantity demanded is 500. So, if Pepsi decide to decrease prices to, for example, 29p, by Pepsi significantly lowering their prices from £1 to 29p, they will expect their quantity demanded to exponentially to massively increase. Why? Since prices have decreased significantly. However, if we look at the diagram, this is in fact not the case. Let's see this. So, going right for 29p, again, would be using a ruler, and we go down from there. This is our new quantity demanded, which would be around 700 quantity demanded. Now, let's look at the axes. We've had a massive, significant decrease in price and only a tiny increase in quantity demanded. What does that suggest? That suggests exactly inelastic demand. Now, Pepsi's owners are extremely confused by this. They've lowered prices, but quantity demanded hasn't increased enough. The reason why quantity demanded does not increase significantly when Pepsi lower their price from £1 to 29p is due to Coca-Cola's response. Since there's interdependence in the market and Coca-Cola knows, since Pepsi have decreased prices, if Coke does not do the same, it will lose out on quantity demanded as people will substitute away from the more expensive Coca-Cola to the less expensive Pepsi. So, how will Coke respond? They will do the exact same thing to save their quantity demanded. So, because Pepsi have decreased price, Coke will be forced to decrease price to make sure their quantity demanded remains constant. This means, as Pepsi thought when they were first decreasing prices, lots of people will now substitute away from Coca-Cola as we're the cheaper one. However, in reality, due to the interdependence, Coca-Cola will have to do the exact same thing. They will have to also decrease their price to 29p to remain competitive. And that is ultimately why the second section of the kinked demand curve is inelastic due to competition/interdependence. Now, we've covered our demand curve, let's add our other curves. These would of course be, just like Monopoly diagrams, our MR, AC, MC curve. Before we label on the MR curve, I would do this. So, where the kink of your kinked demand curve is, so where this is, you need to label on your equilibrium. So you go from there, you go left, and that will give you your equilibrium price, which is PE, and go down from there, which will give you your equilibrium quantity, which is QE. Let's get started with the MR curve. This is the only other unique curve we have on here. So we start from the exact same point we start at our kinked demand curve, but we go twice as steep until we hit our equilibrium straight lines. Now, that might not make a lot of sense, but this is what it looks like. So just start twice as steep until we hit our equilibrium lines, and that is the first bit of the MR curve. Now, the second section is just go vertical for a bit, so it looks like this. That's all it is. Just rough estimate, just go vertical for a short amount of time, and that is the second section of your MR curve. Now, last step, just like you did initially, go twice as steep from that point, and that would look like this. And now that is your completed MR curve. So it might look really complex initially, but once you've learned it, it really isn't too hard. So twice as steep until you reach your vertical dotted lines, then go vertical for a slight section, then again twice as steep, and that is your completed MR curve. Now, two more curves left to go, our AC and our MC curve. Let's start with our AC curve. It's just a bog standard AC curve. The only rule here is that it has to be in the vertical section of our MR curve. So in just any of this section is where you would draw your AC curve. So looking something like this, AC, and that's perfect. That's all you need to do. And like I said, just in the vertical section, so just anywhere between here. So it could be up here, it could be down here, it could be there, it could be there, just anywhere in this vertical section. Just not, for example, here or here. Lastly, MC, same rule applies, that's always applied, just has to intersect AC at its lowest point, and that should be perfect. Finally, let's finish off with adding the profit maximization points. This would, of course, be where MC intersects MR, so where the blue curve intersects the green curve, which would be here. Now, if you go down from there, this will give us our quantity, where we profit maximize, so QE in this scenario. And then from QE, just how the rule is, you keep going up until you hit your demand curve. So from here, just keep going vertically up until you hit your demand curve, then you go left. And now PE would be the price at where we profit maximize. Lastly, let's find our costs so we can make that box of supernormal profit. So again, going up from QE, go up until you hit your AC curve, which will be here. Then go left from there. Now this entire box is our box of supernormal profits. And as you can imagine, oligopolistic firms, very high market share, so it leads to very large boxes of supernormal profit. And that is the completed Oligopoly's kinked demand curve.